The global economy has always been shaped by information. Those who possess it first, act on it fastest, and interpret it most accurately, control the flow of wealth. But today, a new layer of intelligence has emerged far above the Earth's surface, not in trading floors, not in government reports, but in orbit. This is the rise of the orbital economy. At the center of this transformation are vast networks of satellites, operated by companies like SpaceX, Planet Labs, and Maxar Technologies. These constellations circle the Earth continuously, capturing high-resolution imagery and sensor data in real time. What they observe is not just geography, but economic activity itself. Oil tankers moving across oceans, crop fields shifting in color and density, mining operations expanding or slowing down. Every movement becomes data, and in modern markets, data is power. For decades, commodity pricing relied on delayed, often opaque reporting. Governments released production figures, corporations published quarterly updates, shipping logs were fragmented and incomplete. This created a lag, sometimes days, sometimes weeks, between reality and market perception. But satellite constellations have eliminated that lag. Today, traders no longer need to wait for official reports. They can observe reality directly. Take oil, for example. By tracking tanker movements across key choke points like the Strait of Hormuz or the South China Sea, satellite data reveals supply flows in near real time. Analysts can measure how many barrels are in transit, where they are heading, and whether supply is tightening or expanding. This bypasses traditional reporting entirely. Instead of relying on organizations like OPEC or national disclosures, traders can independently verify supply conditions. And in a market where timing is everything, this creates a powerful advantage. Agriculture tells a similar story. Satellite imagery can detect subtle changes in vegetation health using multispectral sensors. By analyzing crop color, moisture levels, and growth patterns, firms can estimate yields weeks or even months before harvest reports are released. This means that a hedge fund in London or New York can anticipate a wheat shortage in Eastern Europe, or a bumper harvest in the American Midwest, long before official data confirms it. This is where the structure of power begins to shift. Because not everyone has equal access to this information. Processing satellite data requires advanced infrastructure, machine learning models, cloud computing, and specialized analytics. Companies like Planter Technologies and Google Cloud play a crucial role in transforming raw imagery into actionable intelligence. The result is a new class of market participants, data-driven traders who operate not on public information, but on privately processed insights derived from space. This creates an asymmetry, a divide between those who see the market and those who see reality before the market reacts. And in financial systems, that difference translates directly into profit. Consider the concept of informational arbitrage. In traditional markets, arbitrage involves exploiting price differences across locations or instruments, but in the orbital economy, arbitrage is temporal. It's about acting on information before it becomes widely known. If satellite data reveals that oil inventories are building faster than expected, traders can position themselves before prices fall. If crop stress signals a future shortage, positions can be taken before markets adjust upward. In essence, satellites compress the timeline between cause and effect, and whoever operates in that compressed window captures the value. This transformation is also reshaping how governments and institutions operate. Historically, state agencies held informational authority. They collected data, validated it, and released it to the public. Now that authority is being challenged. Private satellite networks can observe global activity independently, often with greater speed and resolution. This reduces reliance on official narratives. It introduces transparency, but also competition over who controls interpretation. Because raw data alone is not enough, meaning comes from analysis. And analysis in this new system is increasingly proprietary. The orbital economy is not just about observation, it's about interpretation at scale. Artificial intelligence models scan millions of images, detecting patterns invisible to the human eye. They identify anomalies, predict trends, and generate signals that feed directly into trading algorithms. This creates a feedback loop. Data from space informs trading decisions. Trading decisions influence market prices. Market prices then validate or challenge the models. Over time, the system becomes self-reinforcing. More data leads to better predictions. Better predictions lead to greater profits. Greater profits fund more advanced data acquisition, and the cycle continues. But this evolution raises critical questions. What happens when markets become too predictable for those with access and too unpredictable for everyone else? what happens when physical scarcity, once the core driver of commodity pricing, is replaced by informational precision? In such a system, volatility does not disappear. It shifts. Instead of being driven purely by supply and demand shocks, volatility emerges from how quickly information propagates and who receives it first. This has broader implications for global stability. Commodity markets underpin entire economies. Oil prices influence inflation. Food prices affect political stability. Resource availability shapes geopolitical strategy. When the mechanisms driving these prices change, the consequences ripple outward. In regions dependent on commodity exports, sudden price movements can destabilize national budgets. In importing nations, unexpected spikes can trigger economic stress. And increasingly, these movements are being influenced not just by physical events, but by how those events are detected and interpreted from orbit. The orbital economy also introduces a paradox. On one hand, it increases transparency. Anyone with access to satellite data can, in theory, observe global activity. On the other hand, it concentrates advantage, because the ability to process and act on that data remains limited to a small group of highly sophisticated players. This duality defines the new landscape. And this brings us to the future. As satellite technology becomes more advanced, constellations will grow denser, revisit times will shrink from hours to minutes, sensors will become more precise, capable of detecting not just movement, but composition, temperature, and even chemical signatures. In parallel, artificial intelligence will continue to evolve, extracting deeper insights from increasingly complex datasets. The result will be a world where the physical economy is continuously mirrored by a digital layer of real-time intelligence. A world where every barrel of oil, every acre of farmland, every shipment of raw material is tracked, analyzed, and priced dynamically. In that world, the definition of an edge changes. It is no longer about access to resources. It is about access to information, and the ability to act on it before others do. The orbital economy is not a distant concept. And as this system expands, one thing becomes clear: the future of commodity markets will not be decided solely on a lard, but in the data streams flowing silently through orbit, because in the modern world, control is no longer defined by what you own, but by what you can see before anyone else.